Good evening, everybody. Welcome to vBrownBag US. Today we have a very special guest, Kendrick Colmen, who's going to talk to us about containers and persistence and how this new technology demands new methods. Just, you know, the little quick notes that we always do. Remember that we will definitely be doing something in VM World with VM Underground, opening next, the party. Remember that we have the Tech Talks. Please sign up if you want to be included. The spots are filling up fast. Get in on the conversation. Those are our Twitter handles, especially our Twitter hashtag. Remember that we have regional brown bag broadcasts, APAC, EMEA, Latin America, US. They're on different days, different times. Now, I'll leave you with Kendrick, and if you need anything, just ping me or raise your hand or ask a question, or ping me on Twitter at Ariel Sanchez Moore. So let me change presenter.
Awesome. Okay, Ariel, can you see my screen?
Yes, sir.
Okay, great. So looks like we're ready to roll. I'm running in kind of dual screen here, and so if there are questions that come up, Ariel, please feel free to interrupt, and we can kind of ask questions along the way. But just to kind of give you guys a quick overview, actually, at first I want to have a first off apology because it is 8:30 here on the East Coast. My daughter is 2.5. She doesn't go to bed till around 10, so there might be some faint screaming in the background. So we'll hopefully that doesn't happen, but I can't guarantee everything with a 2-year-old. This is not my first time presenting on the vBrownBag. I think this is my third or fourth time on here over the past few years. I've had quite a different journey through all this. So of course I've been through with vBrownBag when it was Cody, and we did a lot of stuff in the VMware days. I co-authored a book with Scott Lowe and Forbes Go3 that were focused on vCloud Director, on automation, and I've kind of grown in my career a little bit where I did a lot of things with VMware, and I got to the point where I wanted to start learning something new. It got to the point where, we saw this kind of new rise happening where the term DevOps really started coming around, I'd say probably 3 years ago, and that's when really started to intrigue me, and I figured, well, how can I start getting into this world? And when I realized that, I figured that I needed to start learning a programming language. And so when I started learning this programming language, that's when you start figuring out, like, okay, well, when you deal with Chef or Puppet or Root or anything like that, you've got to learn how to program. You got to know how to do these sorts of things. And so that's when it kind of started leading me down this path. So I started writing applications. And when I started writing applications, I started realizing what automation software really goes into it. And when you start figuring out the automation behind it, you start seeing that there's more efficient ways to do it. And then, probably 2 years ago, maybe even 2.5 years ago, this company called Docker came around. And Docker really kind of shook the world up in regards of how people are going to be running infrastructure. And that's when I sort of saw the light and kind of saw a new path forward. So I've been focused within a new group inside of EMC, and I'll talk a little bit more about that in a minute, but I really saw this light in how new infrastructure is going to be built, how it's going to be ran, and it's very interesting to kind of see exactly what we're doing as well and some of the problems and the challenges that we're solving at the same exact time. So first off, I didn't even say my name. It's Kendrick Colmen. A lot of people know me by Kenny, but you can follow me also on Twitter at Kendrick Colmen. My GitHub account is KACole2, and I work for the EMC Code organization. Just kind of a quick tidbit about our group and what we do. We are a group of open source engineers and developer advocates, but focused on next generation infrastructure. Of course, as I talked about earlier, mostly focused around containers. We focus mostly in the Docker and the Mesos ecosystem, because a lot of the things that we're looking at and a lot of the ways that customers are wanting to run next generation software is going to be in containers. And so we try to figure out, how do we figure out a happy marriage between EMC and the container infrastructure? And we've seen a lot of growing interest around persistence with it. So some of the other things we do is we also contribute to other meaningful open source projects. We have a lot of contributions into things like Glide, other different open source programming languages such as Go. We also do just a lot of things that we utilize on a day-to-day basis. If we see some integrations that we can help with in regards to things like Slack or something like that, we help with regards to there as well. But as I said, the integrations that we are creating today for container-based infrastructures, we see this as a happy marriage because it keeps EMC relevant. For the longest time, people have been saying, well, EMCs, they're a dinosaur, right? Like the day's going to come when software-defined storage is going to eat the world and these monolithic arrays aren't going to be necessary. Well, we kind of see that as like, well, that's a very, very far future state and a very one-biased way to put it. But what we're really seeing is that's not really a buying pattern. People are still buying storage arrays. It's still happening, and they still need centralized architecture as much as we want to move to a software-defined storage state, because these types of storage arrays are very multifaceted. So bringing in the integrations to container-based infrastructures and EMC storage arrays is still a very relevant thing today. We also want to drive open source awareness within our own internal teams inside of EMC, because a lot of people are building products and they have no idea even what containerization is. So we're driving awareness in regards to that as well. And we also act in the interest of building a community. And on the last slide today, I'll actually show you where you can actually join our community, where we have a Slack channel with over 1,400 members. But if you want to go ahead and get to it now, it's emccode.com/community. So how is this all really starting, right? So this is really where the applications are changing, because around the 2000s, even before then, applications were very much a monolithic type of architecture. It had long development cycles. It was a single type of environment. It took a long time to scale something because you could only scale up as much as the infrastructure, the physical components allowed you to do. Virtualization came around, shifted that a little bit. But we're seeing that even virtualization has its own inadequacies when it comes to a lot of these things as well. But we're moving towards some things that are like decoupled services. They're fast and they're iterative improvements that we're seeing, and you can have multiple environments. It's a lot easier to do to spin everything up, whether it's on-prem or off-prem or in the cloud or wherever, and allows you to quickly scale these different things out. So if you're using any kind of different, multitude of stacks out there, any kind of language of frameworks or databases, they're all changing, because we've even seen a database shift, right, where things were looking from a SQL type kind of architecture where it's relational type databases into something where it's NoSQL, where everything's kind of JSON, and it's easy to replicate that information back and forth to multiple types of servers. And we'll talk about how we're solving some of those problems a little bit later. But at the same exact time, as you're moving towards this type of architecture and you're moving towards this kind of way, we're seeing the differences in the types of environments as well. We can see that anywhere from pre-production to QA to staging can be done on-prem, and then maybe even production could be in the cloud. And the container ecosystem is starting to change that as well. And by the way, I know a lot of people probably already have a very good familiarization with containers, so I'm not going to spend a whole lot of time on this. This is just kind of a quick little recap before we get into really the meat of it, which is all about the persistence side of it. And so we know that we have this new matrix from hell where you have all these different types of infrastructure where you can run everything for, all through your development cycle all the way to production, and you have all these different types of applications you can run. And the great thing that containers are changing is how you run all this at the same exact time. So they're suitable to run on any type of infrastructure. And so the container came in, and really a container in its most simple form is a package of software binaries. And this package that enables it to run shares the Linux kernel with all the other containers inside of there. So within there, all the dependencies for that particular application are isolated. A really good example is this: if you think of something such as Solar. Solar is a image processing image, or sorry, actually that's I'm thinking ImageMagick. Solar is an index and searching mechanism. And so if you need that for a particular application, don't rely on the individual server itself to have ImageMagick or Solr installed. Instead, you can have that dependency run inside the container and be isolated into it itself. And when you have this inside the container, again, as I said, it makes it easily portable across any kind of environment. And with this, it's also allowed a huge ecosystem to develop around it. We've seen hundreds of people that are developing new products and new integrations into it. Of course, we're doing a lot of things with storage. A lot of people are doing things with monitoring and management. You're going to see things even coming up later on, maybe into things such as even disaster recovery, if you will. But when you think of even disaster recovery and backup and replication, those are a lot of the things that we thought of in the virtual machine world. The container world is a lot different, because in container world, everything's ephemeral, right? Because if we're in a virtual machine and you lose a virtual machine, all hell is going to break loose. We got to figure out where's the backup to it, where are all these different things, because this kind of goes, again, back to the pets versus cattle argument. But inside a container ecosystem, it really is. These containers are meant to be ephemeral. They have a short-lived lifespan. Some of the use case applications that really people thought of are just going to be stateless. They're going to be stateless applications where you can spin them up, you can kill them off, start them again. And this is also going back to the whole idea of what was the difference between something like VMware and OpenStack. Right, because OpenStack's idea wasn't supposed to be, oh, we can create highly available virtual machines. They said, well, I want to create virtual machines that are stateless in nature, things that can be killed, and I can spawn new ones. I can have rolling upgrades, and they can all live behind HA proxy or some kind of load balancer. Well, that same argument goes into containers, where it's a stateless event, where you can have, again, HA proxy, load balancers, web servers, message queues, all those different kinds of things that don't rely on some sort of data persistence or some sort of data to actually do what they need to do. Maybe it's just something as simple as a configuration file. And so that's where the matrix sort of got eliminated, right? Because now you can run anything inside of a container. So why should you care? And I think this is one of the things that when I was talking to Jonathan about coming on here today and figuring out what do people the vBrownBag really care about, is what does it mean for me as a virtual machine administrator, a VMware administrator, to care about containers? Well, there's two sides of this, right? And for the development side, it's definitely, when you look at a virtual machine, it's a very big overhead process, right? Because I'm going to show you here in a little bit. I've got 3 virtual machines running on this Mac that I'm presenting on, and I'm running about I'd say close to 95% RAM utilization. So it's a huge penalty when it just comes into performance needs, even local development. But some of the other things that allows you to do is, again, a clean and portable runtime environment allows you to have all those dependencies within there, and you don't have to rely on anything that's in the virtual machine that you're configuring. And that even goes back into things when people were thinking of Puppet and Chef and Ansible. What does the container ecosystem, when it means, when you think about what does it mean to those kind of configuration management tools? In my opinion, you kind of look at it and say, well, it might be killing itself, because if all the dependencies for that particular application are contained inside the container itself, I don't need to spin up a virtual machine that has anything but the container engine that I'm going to be running. So that's one of the big things to kind of look at if you're thinking future state and you're trying to figure out, well, the whole Puppet, Chef, Ansible configuration management ordeal, how does that relate to the next-gen infrastructure and dealing with containers? That's one thing you need to figure out for yourself and figure out how that's going to work with you and your company's needs. But at the same exact time, everything's within inside of this own container, so it eliminates those concerns with the dependencies, as well as you have all your integration and testing and packaging for your entire application from soup to nuts. So whether it's just unit tests or whether it's integration tests, that can all be done within inside of the containers themselves. And the second to last bullet point is kind of a big one about the compatibility on different platforms. I know we've all seen the meme before where it says, well, it worked in development, and then you have the girl sitting in front of the house that's on fire, and it said, well, it worked in development. And now it's in production. We have all these things that we throw it over the fence, and now it's their problem. But that's ideally what the whole thing about containers is going to be, is that, you know, whether I'm doing local Rails development on Mac and I can push that local Rails development application into a Docker container or into any kind of container, and I can run it inside that container and it has the expected outcome of what I want it to do, then I know that's how it's going to perform in production, because it has all the same dependencies, has the same underlying Linux operating system base image or whatever it is, so I know exactly what I'm going to expect when I get there. Now, on the ops side, this is something that most of us, and I come from an ops background, I look at containers as the next evolution, because it's a lot more efficient and consistent and repeatable. I think that's probably the biggest thing about this, is that when you're looking into doing integration testing and you're looking into your company doing multiple rollouts and trying to be more like Etsy or trying to be whatever it is and doing all these pushes per day, well, you know that your code is being tested in a certain fashion with inside of a container, that it's always being tested in a way that is going to be moved to production as well. So you're improving the quality of code that's actually coming out of the development lifecycle as well. And at the same exact time, you're also improving the speed at which you can deploy, because if somebody is just pushing to GitHub, well, you can actually integrate GitHub or GitLab or whatever it is, any of those distributed version control systems, into any sort of CI/CD system such as Jenkins or CodeShip or Travis, or you name it. There's plenty of handful of them out there. But when you do that, automation sort of takes over from there. And when automation comes in is when your life gets a little bit more simple. So when you can have your tests be automatically ran for you, whether the unit tests or integration tests, then automatically it can be pushed to production with all the green check marks going there. So you've got a lot more speed and reliability for your production systems, and you're starting to get away from that ideal or that mindset that says, well, we can only push once a quarter or once every month or whenever it is, because it's a huge headache or a huge pain to be able to do all that sort of stuff. Again, going back to the development lifecycle with having localized versions of virtual machines, think about what it means to have the performance of 100 virtual machines taken down into one virtual machine and 100 containers. We'll kind of just get to that here in a second, but that kind of just gets to show you, what we're looking at in regards of performance, overhead, and those sorts of things. So that leads us into our first demo. So I'm going to go ahead and exit out of here real quick. And I have got a demo environment set up right here. And this demo environment is actually using a Vagrant package. This Vagrant package is spinning up a 3-node Scale.io cluster with a few other different things inside of it, but I'm not going to bore you too much with that. Let me just go ahead and SSH into this first machine right here. And hopefully all the demo gods are on my side tonight, because the last thing I want is to sit here and try to fill space while things aren't working. Okay, so let me go ahead and clear this. Can anybody see this, by the way, or do we need to blow up the font?
It's good. I
blow up the font? Okay, well, I'll blow up the font anyway. So I'll just do a simple one, right? So we'll do docker run ti. We'll do the name, such as, we'll just say web server. And we're going to do the Nginx image, right? So what it's doing is actually, this is a Docker container. We're pulling down the Nginx web server. And actually, before I do that, I realized that I ran something wrong. I need to specify a port here. So once this all gets pulled down, I'll go ahead and fix this. But Docker is actually running an image layer file system. These these layers are certain different pieces, right? So that base layer, that F1, F5, that could be something such as Ubuntu or CentOS or Alpine or anything like that. And that doesn't change in regards to all those. So as you need to update different things, that image is only going to get updated as the images from the Docker Hub location are going to change as well. So this is going to probably, it's not going to fail off, but it's really not going to do anything because I don't have any ports shown as well. So give me 1 second, and I'm going to come over here. I'm going to do vagrant hosts list, just so I can see what all my IP addresses are. So I can see that I've got 3 different virtual machines right here. They're all running Scale IO. I've got my MDM1, MDM2, and my tiebreaker. And I'm going to go ahead and just kill that real quick because it's not going to do anything good for me. See, it didn't even actually run. So we'll go ahead and we will remove this. All right, so we will do, let's try this again, and we'll specify the port as 5000, and we'll go inside of port 80.
So what's the first 5,000 there? I imagine 80 is the web server port.
Yeah, so what we're doing right here, sorry, thank you for asking that as well. I should have mentioned that. So what this is doing is this is exposing port 5000 on the host itself. So that host itself is 50.12. And what it's doing is it's exposing itself into port 80 inside of the container. So this is where you get into allowing yourself to have multiple containers sharing the same ports, right? So I could have 50 different web servers all running Nginx, and because I'm running with TI, that would be why.
And everybody has a different port, etc. Okay, got it.
Yes. Let me run this as web server 2 as well. There we go. Okay.
Graham says it's like a container NAT.
Yeah. So now what I want to do is if I want to come over here and I said I was on this particular host 50.12 and I go to it and I should need to go to port 5000. It should have worked. Let's see what we got going on here. So we can see 5000 is pointing to there. I am on MDM1. What's going on here?
We got a suggestion here that maybe you don't want to do HTTPS since you made it in port 80.
Oh, yeah. You're totally right.
Thank you, Larry Smith.
Yeah, there we go. That was easy enough to fix, right? So there we go. So now we have Nginx up and running inside of a container. So that was pretty easy to kind of just see. And we can see that if I wanted to run Nginx, if it was inside, it had some sort of configuration file or anything like that, that'd be very easy to give it. But to kind of relay on what you were saying, Ariel, about the ports, this is where I can have, again, 50 different Nginx servers all running the same exact type of application, load balancing across, and this server could be having anything from port 5000 to port 5050, all pointing back to port 80 inside the host itself or inside the container itself. So then from my HA proxy or my load balancer, I could specify port 5000 to port 550. It can go through any one of those particular containers to do whatever it needs to do. Okay. So let me go ahead and kill these two real quick, because I've got a problem where if it's not killed, I ended up always forgetting about it, and it ends up biting me later on down the road. And sudo docker remove. Okay, so back to clean running environment. Let me go ahead and bring this over here and continue on the presentation. I'm not going to beat anything more containers to death. What just happened, we kind of just talked about that. What we're doing is we're going to the Docker Hub. We're pulling the Nginx. The Nginx image has a Docker file attached to it. This Docker file actually lives inside of GitHub. And the Docker file is the, I guess you'd say, the syntax of how you actually build a container image itself. And we go ahead and we push it out to a container. So what's the difference between a container versus a virtual machine at this point? Well, we've kind of already said that a virtual machine is very heavy, right? It's got a lot of stuff that's built into it. You have all these guest OSs that are going to be building up over time, taking up a lot of RAM, a lot of CPU cycles. It kind of is Moore's law when you think about it, when we went from physical infrastructure to virtual machines, and now we're going to be moving into containers. So we're getting smaller in our footprint and the ability to be able to run our applications, because all the binaries and libraries and applications are sharing the container runtime or the Linux kernel itself, instead of relying on the hypervisor to create that sort of isolation. So when we start thinking about, what's next, we kind of showed a stateless application with Nginx, but there's coming a point where people are wondering, well, I can see a virtual machine as my unit of infrastructure today, and this virtual machine is a packaged thing. It contains all the state I need for a particular application, whether it's a database or Redis or a key value store, or it's a gaming application or whatever it is, and it has some sort of state. It's all wrapped inside that virtual machine. In that virtual machine, we can vMotion it. We can utilize high availability, we can copy it off, and we can put it to a hard drive, and we can ship it to China, and we can load it up somewhere else. There's tools out there that we can take our own virtual machine and we can run it in Amazon. But when you think about it, the virtual machine overhead is really a big sort of thing. And we at EMC Code, we look at containers as that next unit of infrastructure, that next way you're able to run your application. And it doesn't really matter what type of application it is. So if it is stateless, that's great. You've made life 10 times easier. But what if it is stateful? If it's a particular application, such as a database or as the gaming engine or anything like that I kind of talked about before. And this kind of goes back into, this was a slide that I stole that was from Ben Heineman, who is the co-creator of Apache Mesos, that he gave in MesosCon this past year. And he said there's no such thing as a stateless architecture, because a lot of people look at Docker, they look at containers and say, like, why would you run something stateful inside of a container? Because they want to try to run everything stateless. But the problem is that, there's going to be data. They have to pull data from somewhere. And are you just going to be able to continue to run things inside of virtual machines from now until infinity and the end of time? Well, of course you can, but there's better ways to do that, and there's more efficient ways to do that. And at EMC Code, that's the way we look at the next iteration of what we want to do with containers, is we want to be able to run anything we want with them. We want to be able to move from a virtual machine first policy to a container first policy. And it doesn't matter what type of application it is, because we can now be able to run all those different kinds of things inside a container as well. Today, if it runs on Linux, it can run a container. There's really nothing really stopping it at this point. Won't go too much into Windows, because you have to kind of look into the deep dark hole of the Windows threads for Docker to figure out what you can do. But I mean, there's already blog posts out there, people that are running SQL Server with Docker. So being able to do that even with Windows applications are happening already today. So running a stateful service, whether it's as I said, a key value store or a database or something like that, is something that's very, very possible to do today. So your entire application can ship in a unit of containers. So the problem today, when we look at it, is that when I run an application inside of a container, where does this data really get stored? And that container itself holds the entire structure of the application. And if you start reading and you start learning a little bit more about volumes, you do have the ability to run local volumes. And this Docker run command that I have down here, I can see that I'm now exposing a local volume into the container using that -v flag. And I'm doing this with what's the Redis image itself. And as I said, stateless applications, they work very well here. But if I want to, if something ever happens to the container, to the server itself, I'm kind of SOL, right? I've lost my data completely if I lost the container. If I lose the container and I don't use local volumes, I've lost all my data. If I am using local volumes and I lose the server, then I've lost the data as well. And not only that is if I'm using local data storage, I mean, this just goes back into the old adage of even using physical servers, is that you can only scale beyond what that physical server is actually able to do. So if I have a failed RAID card, or if it only has, say 48 gigs of RAM and 2 terabytes of hard drive, I know that's nothing today. We have all our laptops are even maybe pushing maybe 48 gigs, maybe not so much, but 2 terabytes of space. But I'm just saying, you have this ability to scale beyond there, but you have a limit there. And being able to transfer that data to be able to move to a bigger server without having to shut it down and do hardware swap outs, you're kind of going back in time. So that's some of the problems that we're seeing today. And when we look at Docker Hub itself, 7 out of the top 12 applications inside of Docker Hub require some form of persistence. So whether you're looking at something that is a database, like Mongo or MySQL or Postgres, or you're looking at something like a key value store like Redis, or even a big data application like Elasticsearch, those are all one of the top 12 applications that are on Docker Hub today that people are actually using. These all have millions and millions of polls, and they have thousands of stars, and so they're being used today. They're being used. Maybe they're in test dev environments. Maybe they're just being used to kind of just mess around with. But some of them are actually being used in production. And so figuring out how we're going to be able to use these in production and have these applications that require persistence move on is something I have to figure out. So this is where EMC Code has come out with a project called RexRay. RexRay is an open source project, and you can find it at EMC Code/RexRay. Here's a little bit more information, going a little bit more deeper in the weeds with it. So we have integrations into some of the major platforms out there for containers, of course into Docker and Mesos, but Mesos particularly with Marathon. Marathon is one of those frameworks that allow for long-running applications. We also have integrations into Kubernetes. So if you are looking into using K8 with your infrastructure, we also have an integration into there. We also have support for multiple storage platforms. So one of the things that we're doing is we're utilizing this as a Docker volume driver. That's the easiest way to kind of put of what RexRay is at the end of the day. Is it's a way to create a bridge, or to create a communication tunnel between the container runtime, which is Docker itself today, or the native Mesos containerization, and have it be able to talk as a native, or to talk to the APIs that it needs to be able to talk to the backend storage system, and have it do all the storage orchestration for you, for mounting, unmounting, creation, deletion, all those sorts of things. Of course, we support our own on-prem solutions for all EMC sort of things. We also support Oracle's VirtualBox. VirtualBox is kind of unique in regards that you can now have RexRay run in your entire development pipeline from start to finish. So if you are developing locally on VirtualBox, and you're creating maybe a Docker Compose file that has multiple containers, and some of those need persistence because it's a database or some sort like that, the only thing that's really going to change is a configuration file of what RexRay actually needs to be able to use to be able to talk to the API or the backend storage system itself. So you could be using VirtualBox locally, and perhaps you're running AWS in production, and then maybe you're using something in the middle for QA or staging, or maybe you're just using AWS and QA staging, and you're moving something on-prem for production. You can utilize RexRay through all of those, and so your configuration file for your Docker Compose instance doesn't have to change. It can specify RexRay as part of the volume driver path, and I'll be able to show you that as well here in a few minutes, just when we go through the demo itself. RexRay is also one of the only solutions today on the market that is providing high availability, and we do this through a feature called preemption. And when we think about high availability in a VMware sense, we think about, well, what happens if a host goes down? Well, high availability in a container world can be a few different things. It can also mean when a host goes down, but when that host goes down, it needs to rely on something such as an overlying orchestration framework such as Docker Swarm or Kubernetes or or Marathon to be able to understand when that host goes down, how do I restart these containers somewhere else? And not only that, our preemption feature does a forceful detach and unmount from the previous host and can now move it to a new host. So the one thing that hasn't been solved in the land of containers, and which honestly it probably shouldn't be solved, is the idea of what is vMotion that we all have come to love and learn. Is how do we have a running application that doesn't lose its a single ping or anything like that? Well, what we can do with high availability inside of RexRay is I can start one container on another host, and then I can request and start another container on another host, requesting that same exact volume that another host is using, and it'll do that forceful detach and unmount and move it to the next host with only a few seconds of downtime involved. So you're not getting to the point of vMotion where there's no pings lost at all or anything like that, but we're getting to the point where we only have a few seconds of downtime. Again, the great thing about RexRay is it is completely open source, so we accept PRs for any other storage platform that you're thinking of. So if you work for any other kind of storage vendor or anything like that, we have another project that we have going and kicking off, which is called libstorage, which is actually underneath the covers of RexRay. And libstorage is a library that does all of essentially the workhorse of RexRay, that knows exactly what type of storage systems it's talking to and does all of the orchestration itself. So it's an open source project that we're looking to bring in a lot more companies into the fold, also a lot more different cloud solutions and cloud storage pieces into it as well. The other great thing that makes RexRay so simple is that it's a single binary. You do a curl bash install script, and you configure it using a single YAML file. And I'll be able to show you that here in a demo as well. Not the installation, but I can show you the YAML file of how easy it is to kind of just get set up and get going with it. So what's this look like when you solve the problem now? Well, we showed you before, if you lose the host, you lose the container, you lose the data. Well, what this is doing is this is actually using the Docker volume plugin framework, where it's allowing the Docker daemon to request, to do API requests to the volume plugin itself to do storage operations and storage orchestration, such as creating, unmounting, deleting, snapshotting, all these different kinds of things. So you install RexRay on every single machine. And with that, you say I'm going to do a Docker run command. I'm going to specify the volume driver as RexRay, and I pre-created a volume called Redis data. And this Redis data lives on the storage array itself. And we're mapping that into the container. We're mapping that, actually attaching it, mounting it to the host that's going to be running this container, and we're mapping that into the container, and we're mapping it to the folder inside the container called data. And inside our Redis, data is the main folder that holds all the persistent storage that would be needed. So now if I lose the container, I lose the host, it's fine, because the actual data itself is actually remaining on the storage array itself, and I can spin up that container on a different host, and now it's back to running to where it was before. This is the equivalent of doing a hard reset, where an application is just going to start and resume from the last write to disk. At the same time, you're achieving a lot more scalability, because we can now go to the maximums that are supported by the storage platform itself. Just another graph of kind of how it looks. So if you have something like Docker Swarm that owns multiple hosts that are running all inside of Docker, you have the ability to run RexRay on every single host. RexRay and Docker all work in unison. And it's now going to be requesting volumes, attaching volumes to the particular pieces. So as you can see on the third host over there, we're going to be running the Redis container, and it's going to be mapping data into the persistent volume, which is called Redis data. So with that, let me go ahead and I'll spin up one more demo here. Let me go ahead and clear this off, and I am going to go into MDM2 here. Whoops. Take this to the other side. Okay. So I want to be able to show a pretty cool demo right here. So is people familiar with Minecraft? I'm sure if you have kids, you might be. So what we're going to do is we're going to dig through and actually run through a Minecraft piece right here. And before I get this, I'm going to go ahead and start downloading these into my particular host right here. So I'm going to do a sudo docker pull here and sudo docker pull here. And we're going to start building this out. So when we need to look for something, so we have this particular image right here, which is hosted by this guy, It's G, and he's got a Minecraft server. This has already been pre-created. This is nothing that comes from me or anybody else, but he's got a lot of things that are already built inside of here, and he tells you exactly how to run it. And he also tells you how to attach a directory to it. So instead of reading all through this, I'll be able to show you directly from the Docker image itself or from the Docker file. So if we look inside of a Docker file, we can see this is how the image is being built. It's not an image itself that's going to be downloaded that, as we can see from here, that it's going to be a couple hundred megs or anything like that. What it's doing is it's actually building it based upon this Docker file. So within here, you can see that it's starting from Java version 8 because Minecraft is all written inside of Java. And within here, you can see that since it's using apt-get update, it's using some form of Ubuntu underneath Java. And from there, it's running a few different commands to install everything regards to Minecraft. We can see right here it's adding this particular repository of where it's going to be getting it from, where it's also exposing a few different ports. So it's exposing the port outside of here. And we can see that right here is the line we really care about. It's called volume. So we see data, mods, config, and plugins. So I'm going to go ahead and I'm going to open up Sublime real quick, and we can start kind of tackling this. So what we want to do is we're going to create a few different volumes. So I'm going to do Docker volume create, and I can show you that what that really means when all these get downloaded. But the Docker volume create command line is a command line that's, as you probably guessed, just all about volume administration. And I'm going to specify the driver as Rexray, and I'm going to do the name as Minecraft. And I want to make one for each one of these. So this could be data, and I'm going to specify the option, which is an option that is only available to Rexray, is the size I want to be able to create is 5. And I want to make a few of these. So I know I've got data, and I've got mods, I've got config, and I've got plugins. And to make all this go in one fell swoop, I'm just going to add the ampersand, double ampersand right here to make all that happen. So that's probably still going, but let's figure out what we need to be able to run to actually make this Docker container go. So we can see that if we do a Docker run, we can expose port 25.5.65 into the container itself. But if we go down a little bit further, the one thing that we do need is we need to specify this EULA here. So let's go ahead and let's take this, and we'll specify this as our next command that we need to run. Now, the one thing that's missing right here is, of course, everything for the volume support. So we come down here to the volume support, we can see that the V on here is it's saying I need to figure out the path on the host is going to be mapped into the data directory. Well, with inside here, what we need to do that as well. So first we're going to specify the volume driver is equal to Rexray. And now we're going to specify all the volumes itself. So we're going to say that Minecraft data is going to be mapped into data, and we need the Minecraft mods is going to go into mods, and you kind of see where I'm going with this. Config is going to go into config. And our last one we need is plugins. And that's going to go into plugins, right? So that's actually our Docker command that we're going to be running to make all this magic happen. So we can see that the Docker command or the Docker file has been pulled down within each one of these. I can see that if I do Docker image list, or let's see, sudo Docker image help real quick, see if I can figure it. Oh, I'm not too worried about it. Well, let's go ahead and I'll use the
sudo docker images.
Images, yes. See, there you go. Okay, so we got Minecraft server there. Thank you so much. This is what happens when I try to do it all underneath the pressure. So now I'll do Docker volume list, and I can see that I have one volume that's available to me. And I'm going to go ahead and I'm going to run this command right here. And again, this is all running in a Scale.io environment with 3 different hosts. And Scale.io, if you're not familiar with it, comes from EMC. It's a software-defined storage solution. So now I can do the volume list, and I can see I have all these available. And if I go to MDM2, of course, what you're going to expect is I'm going to see the same exact volumes that are going to be available to me. All right? So let's go ahead and let's start this container. So it's going to take just a few seconds to load up, and while that's going up, I'm going to go ahead to my applications here, and I'm going to grab Minecraft.
By the way, Larry said that if anything is failing in your lab, it's probably because of lack of bourbon.
Yeah, that's a hard or true possibility there. So let me turn off the music real quick so it doesn't get too loud. And before we try to connect to it, I'll just do a tail on the logs here, just so you can be able to see it be brought up. As you can see, that's the unique identification of the name, or sorry, of the container that's being brought up is at 824. Mm-hmm. So sudo docker logs, I'll do follow, and we'll do MC, which is our Docker. So we can see that we're now following the Docker container itself. We can see that it's not finding anything. We're now spawning a new area. So we gotta wait for all that to go. I'm gonna take a drink of water. No bourbon right now. After this, it's probably gonna require one. All right, so we can see that it's up and running, and since this is running on 50.12, I'm going to come back over to Minecraft, and I'm going to go ahead and go to a multiplayer. I'm going to add a server, and I'm just going to call this server MDM1, and this is on 192.168.50.12, and we can see that I can now join the server, right? And if we go back to the logs real quick, let me see if I can, actually, let me go ahead and just kind of run around here real quick, and I'll see if I can't find some trees or something to, I need to just get some things here so I can show you how the data persists through each one of them. Okay, so here we go. We found our first tree here. We're going to kill a tree. By the way, I have no idea what I'm doing inside of Minecraft. I literally just started messing with this like a week ago, and I'm still trying to figure out even how you build like a shelf into a bed into like all these different things. So I'm sure everybody with kids around here is making fun of me because I have no idea what I'm doing. But so we can see we've got some things down there. If I go back over here, I can see that with inside of here, I can see that EMC code has now joined in, and I'm part of that particular server.
Yeah.
Right? Pretty cool. Not going to disconnect. In fact, what I'm going to do is I'm going to come over here and I'm going to completely kill the container itself. So do sudo docker ps and sudo docker stop, and I'm going to do MC, and I'm going to completely remove the container too, right? So what this is going to show you is that not only I stop in the container, as you can see that I've already lost connection to the server, but I'm also removing it completely. Right, so that's showing you that it's a very ephemeral thing, right? Think about doing this with a virtual machine. That would be very, very hard to do and be like, it's okay, my data is still safe. And I'm going to go into a completely different machine now. I'll go into MDM2, and I'm going to run the same exact command. So as you can imagine, what's probably going to happen is that since this host has access to those particular data volumes that are there, that it should be able to just pick up right where it left off. Now, the only thing that's going to be different is that I can't connect back to MDM1, but what I need to do is I need to connect to MDM2. So this is 192.168. What is it? 50.13. You can see MDM2. We can see that the container is still coming up, and there it is. let's see, let's refresh it. And we'll do a sudo docker logs mc. And there we go. So we can now join the server. We can see it's up and running and ready to go. And as we noticed before, I had those things in my inventory. So if everything worked the way it's supposed to be able to work, then those things should still be in my inventory. And as you can see, there they are. I've got 5 pieces of wood, 2 berries, or whatever it is, right?
Mm-hmm.
So again, that just kind of just goes to show you, you know, the things that you can bring into persistence, right? I wanted to be able to show you something that's a little more fun, such as a game and holding the data in the server in itself.
Mm-hmm.
But this, of course, applies to anything that needs to persist data. So whether it's a database using Mongo or Postgres or MySQL, or that one random Java application that somebody has built in-house and needs to rely on some sort of persistence, some sort of data that lives outside of it, all these things can now run inside of a container. And that's one of the things that it's being able to be built upon.
Awesome. So I do have one question from the audience. And
Yeah.
it's, the question is, it seems that each container can, you know, just like if it was a disk in the server, it kind of has to have exclusive control to that volume on the EMC array. It's not a thing where several Docker containers can actually write to the same volume, right?
So think this is all just going back to the nature of block storage, right? So in the world of block storage, you can only have one host that has a lock right on a particular volume or a particular export, right? So that's not going to change. Now, you do have the ability to have multiple hosts you can have one that actually has read-write access, and then you can have multiple hosts that have read-only access. Actually, you shouldn't say you don't have multiple hosts. Since you have one host that has the lock on it, you can actually have one container that has read-write access, and then you can have multiple containers on that host that have read-only access. So if you are running an application where you have the container is the database and it has the lock for read-write, and that's doing all the read-writes, and then you might have a few different controller, you know, stateless applications that are doing just basically read-only pulls from the database itself, then those can be in a read-only state. So when you think about this, you just kind of have to go back to the soup to nuts of what is storage in general, even in a VMware state, is that only one host can have a lock on it. So even if you think of VMware, you have multiple ESXi hosts and you have multiple data stores. Well, only that virtual machine is essentially a set of folders, a set of files inside that data store, and that particular file is a lock, right? So that host has a lock on that particular virtual machine until it's unlocked and can be moved or turned off or anything like that.
Right.
I hope that answered the question.
No, you're right. BMFS is a very, you know, a lot of hosts have read and write, sorry, to it. But you're right that in any particular file in there is owned by one host only. So I do get what you're saying. Definitely something that with OpenStack and with containers, your application has to match this kind of capabilities, right? It's not like you're going to bring a Windows cluster and say run it on a container and it's going to be the same thing. It's a different thing.
Right.
All right. And we did have another question on containers, and I'm sorry that you're explaining so much in containers, but that is our audience.
Quite fun.
Tell us a bit about Docker security, because you know, one thing that we've always heard is VMs are separate OSs, et cetera, et cetera. I do get that each container seems to run its own kernel, right? So I guess that it's the same, basically.
Yeah, so I'm not going to sit here and try to be an expert on security because I'm not.
Mm-hmm.
This is something that even Docker has their own. Diego Monica is the lead security person for Docker. So they have a lot of blog posts. He's even got a lot of videos out there of what Docker is doing in regards to security. Security has gotten infinitesimally better, or should I say, gotten a lot better since the early days. So there's ways that you can have keys that are being able to, I guess the best way to be able to put it is to be able to say that the author has a certain GPG key, and you know that when you download it, it has this particular key to it as well, so you know that nothing actually happened to it. So in regards to that, security is getting better for the images itself. Now, there might be security questions of container to container, like can a container infect another container because of some vulnerability inside the Linux kernel. I can't really go into that because security is not really my forte, so sorry I can't dive into that much, but there are probably plenty of blogs and other websites out there that'll give you that sort of information.
All right, Diogo Monica, I'll send it out through the vBrownBag if anybody wants to read that. And finally, I have, can IP tables apply to Docker containers yet? I remember this is why I didn't mess too much with it, from Paul.
So again, that kind of goes back to a little bit the security, where I'm not the biggest, it's not my biggest strong suit. Mm-hmm. So that I'm not entirely sure where that kind of sits in regards to IP tables. So I can't. I'm not going to even try to BS my way around it. I'll just try to just tell you that I don't know, that I'm not going to be the one to be able to answer that one for you.
Awesome. Well, I think that's about it. Unless anybody else has any other questions, maybe I can open a microphone. If anybody wants to speak, just let me know I want to speak, and we'll open it up.
Yeah, that's fine. I'll go ahead and kind of just wrap up, kind of this last slide here.
Go for it. Sorry.
For anybody that is interested, we have all of our open source projects from EMC on emccode.com. Of course, that is going to change here in probably like 2 to 3 weeks with the whole merger that's coming. So emccode.com might be delemccode.com relatively soon, as well as our GitHub page. So hopefully we'll have everything forwarding here relatively, like I said, soon in the next 2 to 3 weeks. For anybody that has access into the EMC VLab materials, we actually have a pretty much the same exact presentation that I did today, but using Postgres, but also using Mesosphere with EMC's VLab using Docker and Mesos and Scale.io. This particular demo using Vagrant with Scale.io is on Vagrant, but as I said, RexRay has, and libstorage is the underpinning library, has access to multiple types of infrastructure. So whether it's AWS, GCE, OpenStack with Cinder, VirtualBox, or EMC, we support all those different pieces. And lastly, if you just want to learn more, know more, please join us on our Slack community, emccode.com/community or community.emccode.com. You can get there. Last I checked, we have a little bit over 1,400, maybe encroaching on 1,500 members right now. So we've got channels relating from every kind of programming language to our Premiere projects, to general channels, to random channels with cat pictures that get put in them. So it's just a easy way that you can kind of just get put into a community that's kind of looking at next generation infrastructure.
Awesome. Thank you very much, Ken.
And I'm open to, right now I don't hear the kid talking too much, so I can answer any other kind of questions that you all have.
Mm-hmm. Looks pretty quiet. Nope.
You guys want me to waste time and keep trying to figure out what I'm doing inside of here? Oh, see, it's already dark inside of here, and I have no idea what I'm doing. I was supposed to, apparently I watched a video on what you're supposed to do, and you're supposed to have a bed built by now or something like that, and I haven't even gotten that far.
Oh, one thing that was mentioned before, and I forgot to mention. So how is performance in a container controlled? Like, do you tell it, give me a container with 128 gigs of RAM or 512?
Yeah, so within there, you actually have those kind of restrictions. So when the VMworld space, or sorry, the VMware space, we're used to, oh gosh, I can't remember the name now. Restrictions, what are they called? Constraints, right? So we have constraints, right? So that sort of thing works inside the Docker world as well. So you have constraints inside here, and you can say like an affinity as well. So you can use constraints to say, like, I only want this container to use, like you said, like 2 gigs of RAM or to whatever it is, or this much CPU in megahertz. So all those things exist inside of there. So you can do all those things with inside the container itself to be able to do that. And if you're thinking of, well, what do I need to do in regards of actually like monitoring these? There's a lot of different things that are out there. There's an open source project called cAdvisor that actually comes from GitHub. And GitHub is a way to analyze your performance inside of Docker containers. So you spin this up and you run it. As you can see, it all even runs inside of a Docker container itself. And you're up and running, and you can actually see all the hosts, or all the containers, and you can have kind of an insight into those. So cAdvisor is, of course, an open source solution. There's another pretty good open source solution called Sysdig. Sysdig is another good one that you can kind of look at, that is a way to kind of get deep down into the metrics of performance monitoring into the container ecosystem as well. But if you are looking into just simple constraints of how do I limit a container to not go haywire and start taking over an entire host, all those same kind of guardrails are there that you've been used to inside of the VMware ecosystem.
Excellent. Well, Ken, I think you showed us the persistent storage. Pretty cool that EMC is doing this and also open sourcing it. Thank you so much for the presentation. A lot of people are saying thanks, and that it was very interesting.
Well, I'm very happy to.
Perfect. Okay, I'll start the recording now.